Hi, welcome to the Calculus 2 lecture series. And this is unit number 2. We are talking about the different techniques for the integration. We are still in the lecture number 7 with regarding to the trigonometry integrals here. This is the part 3 of this lecture. On the previous 2 parts, first part we talk about the function with the sine, cosine, the power of sine, cosine. Then the second part, we talk about how to integrate it if you have functions combine the tangent and the secant or cotangent or the cosecants, right? And what type of the identities we use here. All right, so now the third part, we're going to talk about how to integrate. We're going to introduce 2 formulas, and one is what is the integration for tangent x and what is the integration for secant x here, because those will be able to help us to solve the problem, like from the part 2, when we have the tangent and the secant combination, and sometimes it's very difficult to do. All right, so let's go to our lecture notes here. All right, so here is a lecture notes. Okay, so for here, what we're going to do is we're going to talk about the integral for the tangent x and the secant x. Right, so we're going to introduce 2 formulas. One is for the tangent x and one is the secant x. So it's not like a tangent and the secant combined or sine cosine combined just by the tangents here. So the first formula we want to talk about is the tangent x. So the tangent x, the tangent x dx. Okay, so the formulas here, the formula for the tangent x, this is the natural log of the secant x plus c. I'm going to take a look at why. And then the next ones here we're going to talk about is this is the formula for the secant x dx. What is the secant x dx? So this will be equal to the natural log secant x plus tangent x. All right. Okay, so now let's take a look at our first formula. So the tangent x, why the tangent x is equal to this one. And in fact, the proof here, this one is very easy to prove here because we know the tangent axis, right? So tangent x, so the tangent x dx, tangent we know is what? It's a sine over what? Sine over cosine, right? All right, so because we, in the part 1 of this lecture, we like the combination of the sine and the cosines here. So I know I can do what? I can do u sub, right? So I can say here, okay, so I would say the u is equal to cosine x. Why I want u equal to cosine x? Is because here. Remember that because in here we have the sine x dx, right? So I will say u equal to the cosine x. Then when you do the du, what is the du cosine? When you take the derivative, so what it will be here, cosine will be negative of what? The sine x dx, right? So it will be the negative sine x dx. And then, you can just substitute u sub. So then this one's here will be, so you can say the negative du and equal to the sine x dx. So then these things will just become to what? Will become to 1 over u, and the 1, the du is negative. So from the, calculus 1, so we know what is this integration will be the natural log absolute value of u, right? Because the plus minus, the value will be the absolute value. So what is the use here? This will be natural log. So this will be the Okay, so sorry here. So this will be the, so we have the negative, right? So we have negatives here. So the negative, okay, so now this will be the negative and the u to the -1 plus c. So u is cosine. So what is this one here? This is will be 1 over, you know, the 1 over what? 1 over cosine here, right? Okay, so it's 1 over cosine x plus c. So what is 1 over cosine? It's 1 over natural log the secant x plus c. Okay, so this one is pretty easy to show, you know, why the tangent x is equal to the natural log of secant x. Okay, so for you proof this one's here, this one really is require special, you know, the tricks here. You might ask me why you do that. I will just tell you from experience. If you try another way, after you look more, that's you know, that's what will come to your mind. And so most like tell the truth is a lot of time if you never saw this proof before and try to take the integration of the secant x, might not be an easy way to do. Okay, so now let's take a look at this is the secant x dx. So this is the trick I'm going to apply, and this is the trick you probably ask me why. Like I said, this is really from the experience. And if you cannot figure out this trick, if you never saw this before, I think that's perfectly normal because this is a very, very special trick here. So I will put it as secant x over secant x plus tangent x, right? So dx. I just what? I just multiply what? I just multiply once here, right? And like I said, you here you say why you do that? Because now you can see why I do that. Because then if you do like this way, right? So then you take that in. So this is the secant square x plus secant x tangent x, right? Then you have a dx. Now the bottom here, this is the secant x plus tangent x here. Now I can use the u sub again. So I will say, hey, these numbers here, right? So I will say u is equal to the secant x plus tangent x. Then what is my du's here? The du, right? So the du will be the secant x derivative. What is the secant x derivative? It's the secant x tangent x. Now, what is the tangent x derivative? Secant square x dx. See here, that's why the top here, this is all become the du's here. That's why I said you probably will say, how can you think about, you know, try to times this? That's why I said, you know, for the people you never saw this method before, probably it's very, very difficult to think about it this way. And it's really, it's just from like your experience and then you want to do here. So, you know, secant and tangent, the derivatives here is just a perfect match here, right? Okay, so now this one, you can just say, this is what? This is the 1 over u. What? du here, right? That's perfect, right? So what is here? This is a natural log u plus c. So what is the natural log u? U is what? U is secant x plus tangent x plus c. That's how do we get this formula here. Like I said, you know, so for this formula, you know, it's kind of like if you can kind of remember that, that would be easier to use. Or, you know, if you want to derive it, then the times this secant x plus tangent x over secant x plus tangent x is kind of very tricky to think about that. All right. Okay, now let's try to use this result to see how can it help us. Okay, for tangent 3x, tangent x to the cube. We know we like to take one tangent out, and then I have a tangent square x dx, right? So I like to use the what? I like to use the identities, right? So this is a tangent x. So what is the tangent x? Is secant square x minus 1 dx, right? So this is the identity. So remember that we have the tangent x, tangent square x plus 1 is equal to the secant square x, right? So this is the identity we use when we do the tangent secant combination. Okay, so now for these ones here, then you FOIL that. So what do you have here? You have a tangent secant square x, then dx, then minus tangent x dx. So remember, what do we have on the first term? Oh, I like those terms, right? We said that if a secant x is a even number, that's good, because then I can do, so for this one, I can do u sub. So I will say u is equal to the tangent x, right? Now what is the du? Du going to be secant square x dx, right? Okay, so now this thing is going to transfer to what? Will be u du, right? So here, the whole distance become my du's here. So it will be the u du. And the minus tangent x, we just did. What is the tangent x? The integration is natural log of the secant x here, plus c. Now we just need to integrate the u's here. So this will be u squared over 2 minus natural log of secant x plus c. And what is the u here is the tangents, right? So this will be 2, the tangent square x minus the natural log of secant x plus c. All right, so that is one of the application. Okay, so now this is the one last, when we in the second part of this in this lecture, we said here this is the secant x, right? So it's really the secant, oops. So really is the secant for the first power, right? So remember that we said, hey, when the secant is odd, the tangent is even. Remember at the last part, in the second part of the previous video, we said that is very difficult, and sometimes we might need to do the integrated by part and try to do it, right? So this is the example. That's why we did not do any example in the previous video, because we need to use the result from this one, how to integrate the tangent and the secants here. Okay, so now let's take a look. How do we do it? So the first thing is here, we say the tangent square. Oh, well, okay, let's change everything to secant. So tangent square is what? Is secant square x minus 1, correct? And then this is the secant x dx. All right, so now I FOIL that. So hey, this one is pretty good. So this is the secant cube x dx and minus secant x dx. Okay, so we already know from the beginning we derive this formula. So what is this one here? We already know that this is a natural log secant x plus tangent x. Correct. All right. So let's highlight. So let's color coding that. So I know this yellow part I already got it, right? So the things we did not get it is this secant cube x dx. Remember from the previous video, that's what we say, hey, this is probably will give us the trouble. And we say we probably want to do, the integrated by part. So that's why now I'm moving this part out, and then let's try to see how do we solve it, right? And then we can put it back. Okay, so this one's here. Let's see here. Let's try to separate that. So this one is the secant x, and then I have a secant square x dx. So I know I like secant square x dx, right? So I like the secant square. I like the secant square x dx because I can do what? This is the derivative for the tangents, right? So this is good. And so now, but the second is here. That is not a, that is a kind of a troublesome here, right? So I said, okay, now how do we do this integration? So we said, okay, maybe that's what I mentioned from the previous video. We said, hey, maybe we need to do the integrate by parts. Okay, so now let's take a look, because this green part, I already know how to integrate that, because secant square integration is tangent, right? So let's do the UV things. So I will say U is equal to the secant x. So what is the du's here? I know that is the secant x, tangent x, dx, right? So for this part, this is a secant square x dx equal to dv, right? This is the integration by part. So now I integrate. So what is the secant square you integrate? Is the tangent x equal to v. So far so good, right? And then now this one will be equal to the uv, right? So uv, so it will be equal to the tangent x, secant x, okay, uv minus vdu, all right? Remember that, uv minus vdu, so uv minus vdu. So the vdu's here is what here? So will be the second, will be the tangent x vdu's, right? Square tangent times tangent and the secant x dx. Gee whiz, did you see some things here? These numbers here, right? So these things here is back to what I have in my problems here. Is the secant square x, the secant x, tangent square x, the secant x. Oh boy, so I got back to what my original problem. But then we learned how to do this type of problem before. So we say, okay, let's just, okay, this is what my, okay, so this is what my secant cube, right? So now let's put this one down. So secant cube is equal to the tangent x, secant x, correct? Then minus, this is a tangent square x, secant x dx. Then this one we already got the integration. So it's a natural log secant x plus tangent x. Right? Okay. So now because these two, these two are exactly the same. So I can move these two to the left-hand side. So if I move this to the left-hand side, that means I add this integration. So it will give me 2 times the tangent square x secant x dx is equal to the tangent x secant x minus the natural log secant x plus tangent x. That's right. So we already, did that. And of course, you can say plus c here, right? So you can do the plus c. Okay, so now, because I'm looking for the tangent x, secant x, so now I can divide by what? Divide by 2. So if I divide by 2, so finally I get my answer. So this is tangent square x, secant x dx. What is this value? This will be 1/2. Then this is the tangent x, secant x minus natural log secant x plus tangent x. All right, correct. All right, so very good. And then the plus 1/2 c, you can say plus some c star. So this will be the answer. So that's why, this is what we talked about from the previous video. We said if if the the exponents, right? If secant is odd, the tangent is even, sometimes will become very difficult. So we might need to use integration by part. So here, that's why after we separate, so this portions, right, we did here, and this is, we did integrate by part. We use the integrate by part technique, and then the thing here, we see this repeat, right? So that's why we say, okay, there's no need to try to do integration again because this is repeat. So I can just move this to the left-hand side. Now I'll be able to solve the problems here. So this is a very kind of, it's not a challenge type of the problem, right? So you need to kind of, get familiar with, remember what is integration by part, and also you need to kind of the spot, and this integration is the same thing like here. All right, okay, let's take a look at the last one. So this is a tangent x over 2 here, all right? So this one is, I think is a kind of a pretty straightforward, I think it's pretty easy. Okay, so here is the x over 2. Well, I know the tangent x, right? So I would say that I would just do a u sub. I would say, that let me use a different color for the u sub. I would say, okay, I would just say u is equal to the x over what? X over 2, right? Now, I will have a du is equal to what? I will have a du is equal to the dx over 2. Now, in here is only have a dx, so I can move the 2 over, so it's a 2 du is equal to the dx. Okay, so now in here I can, okay, so the 2 du, I can put the 2 here, then this is a tangent u du. One way you can do it, one way you can, because in here, we have limits here, right? We have limits here. So you can replace the limit with u, try to find the new limits, like u is equal to x over 2, then you can say, oh, because u sub, so when x equal to pi over 2, so since u is equal to x over 2, so the upper limit will become pi over 4. All right, and then the lower limit will be equal to 0. Then you can just use u, you don't need to substitute back, or you can just carry out the integration and replace back your x value, then keep the original limit. Either way. Okay, so now let's see here, we already substitute back, so it's 2. So what is the tangent u? We know it's a natural log of secant u, that's right. Okay. So it's a secant u. And because we already replaced with u's limit, right? So here, so this is a pi over 4 over 0. So be very careful, right? So if you use u, then you need to use u's limit. Or if you want to replace back with x, then you can use the original x u limits here. So this will be 2, the natural log secant pi over 4, right? So it's a minus natural log secant 0, correct? Okay, so now the secant, this one's here, okay? So this one, the secant pi over 4 will be the square root of 2, and the secant 0 is 1. If the secant 0 is 1, then the natural log 1 is equal to what? Is equal to 0, right? So the answers here, it will be 2, the natural log square root of 2. Or if you want to simplify a little bit, you can do like this. You will say this is 2 natural log 2, the 1/2, right? Then you can move this 2 inside, use the natural log rule. So it's natural log 2 times 1/2. So we'll give you what? It's natural log 2 will be your answers here. Okay, All right, so this is the third part of the integration, and for this lecture, we just want to introduce two specific formula. One is what is the tangent x, what is the secant x. When you integrate the tangent x and when you integrate the secant x, what is the formula? Like I say, the tangent x formula is kind of easy. You can derive it. Then the secant x is not bad, but the tricks here, you need to know these tricks here, times this secant x plus tangent over secant x plus tangent. Like I say, if you don't have much integration experience, you're probably very difficult to think about these tricks here. And but knowing these two integrations really help out with the problems we have trouble to deal with from our second videos, right? So if the second power is r and the tangent is even, so it's like this one is kind of pretty simple. It's tangent is square, secant is 1. We still need to go through all this, integrate by part, combining it. So it's not an easy problem. It's a little bit of challenge. All right, so the number 3, this is a pretty straightforward integration. Just apply the tangent formulas here. All right, that's it. So we almost covered all the possible trig function of, the possible way to integrate the trig function. And our next video, we're going to talk about the last technique. How do we integrate the trig function if I have a multiplication, like sine x, sine some type of angle times cosine type of angle? How do I integrate those things? All right, that's it. And we'll talk to you later. All right, have a nice day. Okay, and bye.